Hello, ladies and gentlemen. Today, I'd like to go over an activity that you could do at home that could involve, you doing some measurements and you doing some calculations without requiring a great deal of equipment. And I came upon the idea of measuring the thickness of of toilet paper to see what the thickness was. I figured that if anything, on these days, toilet paper is probably something that people have a good deal of at home. Uh, but so that would be one supply that would be easy to get. The other thing that you need is simply a ruler to make some measurements. Um, Before this video, I had you already make measurements on 5 rolls of toilet paper, all from the same brand, the same package, same kind of toilet paper. So 5 different rolls of toilet paper. And as you recall, I asked you to measure both the outer diameter of the paper roll and the inner diameter, the cardboard tube in the middle. So you were supposed to record that value for those two values for each of the 5 rolls of toilet paper and put them into a table. I recall that I asked you to measure that in units of meters. So, for example, if you were measuring them in millimeters, you would convert the millimeters into meters and put that into the table. In addition to the outer diameter and the inner diameter, you were supposed to look at the packaging of the toilet paper and look for information about the number of sheets that there may have been in the toilet paper roll and the length of each particular sheet of toilet paper. You could take those two values, the number of sheets in a roll and the length of a single sheet, multiply them together, and come up with the length of the entire roll. So that's the other piece of information that we needed to have. So the length of the entire roll in meters, and the inner diameter of a roll in meters, and the outer diameter of a roll in meters. So those three things we've already collected for 5 different rolls of toilet paper. So what I'm going to go over today is the mathematics behind calculating the thickness of toilet paper. And I've made a diagram here of a toilet paper roll. It's a spiral, of course, because the toilet paper is wound around the cardboard tube, or wound it around, and creating a spiral. Now, um, as I've indicated here, a spiral of toilet paper can be closely approximated by a set of concentric circles. Those are circles that all have the same center. So if the toilet paper is thin enough, and toilet paper generally is pretty thin, it's a pretty good approximation that each of the spiral turns could be thought of as a circle of a bunch of circles on top of each other. So we're going to use that idea, that approximation, to help us to calculate the thickness of the toilet paper. So here's another diagram of again of a toilet paper roll, this time with 10 circles, and the outer circle here is labeled C1, and the inner circle here is C10. So there's C1 through 10 circles here, and I'm going to go through a formula for calculating the length of the toilet paper roll based on these circles. So here at the top, we see that the length L of the roll can be calculated by making a sum of the circumferences, indicated by C, of all the circles. The number of circles is the same as the number of times the paper is wound around the roll. We will call that number R. So in this example, R is equal to 10. So again, the number of circles here, 10 in this case, would be equivalent to the number of times the paper is wound around the cardboard tube. So in this case, it would be wound around 10 times. That's the same as these 10 circles. Then we give the letter R, capital letter R, to indicate that number of times that it's wound around. So in order to calculate the entire length of the roll, we could use the following formula. Length is equal to circumference of the first circle, the outer circle, plus the second circle, plus the third circle, all the way up to the 10th circle. So here's the equation for that. Put an ellipsis in the middle here, so we don't have to write out all of the different terms of this equation. But we see that there's 10 different terms, 10 different circumferences added together. Now, you recall that the circumference of a circle can be calculated by multiplying pi times the diameter of the circle. We indicate the diameter with a small letter d. So this same formula can be restated so that L is equal to pi times d1 plus pi times d2, etc., all the way till pi times diameter number 10. So instead of indicating their circumferences, we're pi times the diameters. All right, so let's go further in our analysis here of the math. And we can notice that each one of the terms of this equation, for example, pi times d1 is one of the terms and pi times d2 is another term, all of them have pi. They're all, in each case, pi is one of the factors of one of these terms. If one of them has pi being multiplied by a diameter. So since each of the terms includes pi, each term can be divided by pi, so that L is the product of pi and the sum of the diameters. So here pi is taken out of the brackets, so to speak, and then what's left in the brackets is the sum of d1 plus d2 plus d3 all the way up to d10. And that sum is in brackets, and the whole thing is being multiplied by pi. So these, in this case, these two equations are identical to each other. Okay, so far so good. Now we've got a little bit simplified, but now we have a problem. The lengths of all of the diameters are different. And this makes it difficult to find a sum because as you know, D1 is this longest diameter here and D2 is a little bit shorter, and all the way to D10 is the shortest diameter at the middle here. But I say, but wait, there is a way that we can figure out how to find the sum of all those diameters. So let's look at the next page. So recall that when you're adding long lists of numbers, it can be helpful to add the first to the last and the second to the second last, etc. So we've talked about this before when looking at math contests. Sometimes they show us a sequence of numbers all added together, and it's seemingly a huge task to add all those numbers together. And we needed to find a quick and simple way to make that problem easier. And so, as we said, adding the first to the last and the second to the second last, etc., sometimes gave us a very simple way of solving the problem. And so here's an example of that. If we have the numbers 1 through 10 added to each other, we notice that if we add the first number to the last number, 1 plus 10, we get 11. Similarly, 2 plus 9 also gives 11. 3 plus 8, also 11. So that gives us a much easier thing to work with, 11 added to itself a number of times. But the question is, how many times? How many 11s? So it turns out that the number of 11s is half the number of items that were in the original sum. So in this original sum, 1 plus 2 plus 3, there was 10 different numbers, 1 through 10. So the number of times we multiply by 11 is half that number, because it's going to be, half the number of items, because they're going to be paired up. So it makes sense that the number of items are divided by 2. So 10 divided by 2 times 11 gives us 5 times 11, which is 55. So therefore, the sum of 1 plus 2 plus 3 all the way to 10 is equal to 55. So let's use this information to look back at the problem that we were dealing with. Here again, we have the length of the roll of toilet paper is equal to pi times the sum of diameter 1 plus diameter 2 all the way up to diameter 10. If we think back to the beginning of the problem, let's go back to that first diagram. We saw that the outer circumference, this outer circle, what we're calling C1 in our problem, has a diameter which is equal to this outer diameter, the one that you measured from the toilet paper roll. Likewise, the inner circle, C10 in the problem that we're working in now, is its diameter is this inner diameter of the toilet paper roll that you measured, the cardboard tube in the middle. So we have measured those values already. So we have those numbers at hand. So if we were to add those two together, the first and the last, D1 plus D10, it would be equivalent to the outer diameter plus the inner diameter. Outer diameter plus inner diameter. Okay, so that's fair. But what about D2 and D9? What happens when we add those together? Uh, if you look at the diagram, we're going to look at the diagram again. We can look at this diagram. Um, Imagine this diameter of C1 here going across the circle. I wonder if you can think of how it's different from the next circle in, D2, the diameter of the next circle in. If you think carefully, you'll see that diameter 1, or sorry, diameter 2 is the same length as diameter 1 if you subtract two widths of the toilet paper. So here's a width of the toilet paper at the bottom and a width of the toilet paper at the top. So the next diameter down is basically D2 is equal to D1 minus two widths of the toilet paper. So let's see what we can make from that. So D2, as I put in here, you'll see that D2 is the same as the outer diameter minus two widths of paper, or 2 times W. Likewise, D9, the second to last circle, is the same as the inner diameter plus two widths of paper, or 2W. So let's see what happens when we add those together. So this means that if you add D2 plus D9, you get outer diameter minus two widths plus inner diameter plus two widths, which is the same as outer diameter plus inner diameter. So this makes things considerably easier. If you continue with this logic with the next pair of circles, you would subtract four widths from one and add four widths to the other. You will see that this means that all the pairs in our sum can be replaced by OD plus ID. Okay, so that makes things a lot easier. Now we have to figure out how many pairs of OD and ID there are. In our problem, we saw that there was in the example that we were looking at there was 10, but let's look at that for any particular roll. So we said here already that the number of circles is the same as the number of times the paper is wound around the roll, and we're going to call that number R. So R is the number of circles, or the number of times the paper is wound around the roll. And so we can, it says here, as I say here, in the case of our circles, we call that number R. So now we can replace this formula, this lengthy formula here, length equals pi times the sum of these things. Now that we've paired all of these up, these first and the last and the second last and so forth, and multiplied those pairings by R divided by 2, we get this formula here. The length of our toilet paper roll is equal to pi times outer diameter plus inner diameter times the number of times it's round, the paper's round around the roll divided by 2. So L equals pi times OD plus ID times R divided by 2, where L is the length of the roll in meters, R is the number of times the paper is wound around the roll, OD is the outer diameter of the roll, again in meters, and ID is the inner diameter of the roll, also in meters. All right. But we already knew what L was. So how is this, well, here I say that, how is this going to help us find the thickness of the paper? We already knew the length of the roll from the information on the package. This is true, but what we didn't know was the number of times the paper was wound around the roll. This information can be used to calculate the thickness of the paper. All right, so here again is our formula for the length of the roll. Length equals pi times outer diameter plus inner diameter times number of times roll r, or times r divided by 2. Okay, at this point, I'd like you to pause the video and use algebra to create a new equation that shows how to calculate r if you know L, the length of the roll, OD, the outer diameter, and ID, the inner diameter. So pause the video now and on a piece of paper, come up with a formula for R. Okay, here's the way to get the formula for R. Here's our initial equation. L equals pi times outer diameter plus inner diameter times R divided by 2. As you recall, since we want to have R all by itself on the left-hand side of the equation, the first step is to switch these two values so that L is now on the right-hand side, and this whole thing, pi times OD plus ID times R divided by 2, is on the left-hand side. All right, so that's a good start. We've already got R on the left-hand side. Now we got to get R all by itself. So we got to get rid of some of these things that are being done to R, like being divided by 2 and being multiplied by these things. So a good first start here would be to undo being divided by 2. So since R is being divided by 2, we multiply by 2. And of course, whatever we do to the left-hand side of an equation, we also do to the right. So now we have 2L on the right. These 2's, as we hoped, would cancel each other out. So dividing by 2 and multiplying by 2 cancel each other out. And in the next line, you see that a little bit simplified. Now it's pi times OD plus ID times R equals 2L. Now we need to somehow get rid of this pi times OD plus ID times R. Well, if it's being multiplied by, if R is being multiplied by this value, we simply divide by that value, and then we can get R all by itself. So indeed, we take this value and divide by pi times OD plus ID. And we do the same to the right-hand side of the equation. And these two values cancel out. And we're left with R is equal to 2 times the length over pi times outer diameter plus inner diameter. So now we have this value for R. We can calculate that with the values that we've already measured or obtained from the package. Great, so we know the number of times the paper is wound around the roll. Now, how can we use this? So now we have a formula to calculate R, the number of times the paper is wound around the roll. How can we use this to find W, the thickness of the paper? So that's what I call now the thickness of the paper. I give it the value W. Well, let's look again at our diagram of a roll. So here's a diagram of a roll with a lot of concentric circles, and I've labeled it again the inner diameter, which we've measured already, and the outer diameter, which we've measured. And now there's this new value, T, which is equal to the thickness of a stack of sheets. So that's all the sheets going from this central circle all the way up to the outer circle. That T there is that thickness. And if we wanted to know the thickness of a single sheet in that stack, well, all we do is divide T by R. So here's our formula. W is equal to T divided by R. And that's said here. The width of a single sheet of toilet paper, W, is equal to the width of a stack of sheets, T, divided by the number of winds, R, or if you like, the number of circles. Same thing. Now we're left with, we're almost there. We have a formula for calculating R. How do we calculate T, though? Well, here I say I leave it to convince yourself that T is equal to the outer diameter divided by 2 minus the inner diameter divided by 2. So play around with this diagram for a while. And again, convince yourself that T is equal to the outer diameter divided by 2, subtract the inner diameter divided by 2. All right, so take the time to convince yourself of that. I'm not going to go over that proof with you. I want you to think about that yourself. Anyway, once you've convinced yourself that T is equal to this value here, therefore, the width of a single sheet of toilet paper can be found with this formula. Width is equal to outer diameter divided by 2 minus inner diameter divided by 2 divided by r. This can be rearranged. We can divide both OD divided by 2 and ID divided by 2 by 1/2 and take it outside of the brackets. And now we have 1/2 OD minus ID divided by R. Again, a little bit of rearrangement leads us to OD minus outer diameter minus inner diameter divided by 2 times the number of windings or rolls around the paper. So now we have a formula for finding the width. So we can now find the width of the paper doing in 2 steps. First, determining the value of R, the number of rolls, the number of windings around the roll. And once we've got that, we use that value with this equation here to figure out the width of the paper in meters. I put here a last slide. I say here, I won't take the time to go through the proof. However, you can find W directly from L, OD, and ID with the following formula. The width of the paper is equal to pi times the square of the value of the outer diameter, subtract the square of the value of the inner diameter, and divide that by 4 times the length of the roll of toilet paper. So those of you who are a little ambitious, maybe you could try to prove that yourself, that there is, you can directly find the width from those 3 values that we already knew or got from the package. So please go ahead now and use this information from this video to go ahead and do your calculations. You're going to determine for each of the rolls, each of the 5 rolls, you're going to determine the number of times the toilet paper is wrapped around. You're going to find R for each of those 5 rolls of toilet paper. And then you can go ahead and find the average of that value as well, and report that. So, and then finally, once you've determined R, you can also determine the width of the toilet paper from each of the 5 rolls, and you can add that to your table as well. I don't have a device available to measure directly the thickness of toilet paper to verify the result that we get. However, it is there is something we can do. We can measure the number of times that the toilet paper is wound around the roll. I don't. Well, it would have to involve a long discussion with your parents before you actually attempt to do something like this. I myself am trying it myself in this particular way. I'll show you what I've designed here. So here is one of the rolls of toilet paper that I had measured, and what I did was I took a black marker, a Sharpie, and I made a pretty thick line along one edge of the along this. Well, this is the value of T, of course. This the length of this line, and I've done that so that as I unwind the roll, there should be a marking every time we go once around. So I've been keeping track. I got pad and paper, and eventually I will have the entire roll unwound, and I've been keeping a tally of how many windings I have, and then I'll be able to see how that compares to the amount calculated. So I hope you enjoyed this activity, and thank you for watching.